All right, this is 2.14 log modeling. So in this question, we are given a table of values for a function that looks like this. In part A, we need to write two equations in terms of A and B, and then we need to solve for A and B. Pretty straightforward. We are just going to replace x with 1, for example, and fx with 2 over here to get the two equations. So in A, that is going to look like fx is 2. So 2 is equal to a plus b ln 1. That's the first equation. And then 10 is equal to a plus b ln 6. That's the next equation. In part B, that will be equal to 2 is equal to a plus ln 1 is 0. So 2 is equal to a. In other words, a is equal to 2. And from the second equation, 10 is equal to a plus b ln 6, right? And we just sub in the value of a as 2 over here. So this will look like 2 plus b ln 6. 10 minus 2 is 8. So 8 is equal to b ln 6. Let's flip the equation. So b ln 6 is equal to 8. So b is 8 over ln 6. So that is the value of a and b for this equation. Likewise over here, similar situation. So we are just going to sub in fx or gx as 11 and x as 3. So that's equation 1. And likewise, this is 14.5 is equal to a plus b ln 10. That's equation 2. If I want to solve this pair, then I think subtraction will be a great choice, because then a minus a will be 0, right? And we will just be left with b, and then we can figure out what b is. I think I'm going to subtract this minus this. The only reason is this is a bigger number, although when if you do the other way around, you're going to get the same answer, but this is more convenient for me. So 14.5 minus 11 is 3.5. A minus a is 0, and the other thing will be b ln 10 minus b ln 3. So this is going to look like 3.5 is equal to b as a factor, common factor. So ln 10 minus ln 3. Let's flip the equation. So b ln 10 minus ln 3 is equal to 3.5. ln 10 minus ln 3 is ln 10 over 3 is equal to 3.5. And we divide both sides with ln 10 over 3, which is 3.5 over natural log of 10 over 3. So that should be our final value of b. And we need to find a as well. So you can type in a in any equation of your choice. I'm just gonna choose equation number 1. So this is going to look like 11 is equal to a plus, in fact, let's isolate. Okay, let's plug in b. So b is equal to 3.5 over ln 10 over 3 times ln 3. I think let's flip the equation. So a plus 3.5 ln 3 divided by ln 10 over 3 is equal to 11. So finally, the value of a comes out as 11 minus 3.5 ln 3 over ln 10 over 3. That is the value of a over here. Okay. Similarly, the log function looks a little different because it's with a base of 4, but yeah, eventually the process is same. So for a, the equation is going to look like -2 is equal to a plus b log of 1 with base 4. And the other equation is 3 is equal to a plus b log of 16 with a base of 4, right? Okay, in order to solve it, I am just going to well, this is good for us because this is at log 1, right? Log 1 is 0, doesn't matter what the base is. So -2 is equal to a from the first equation, or a is -2, and that we are going to sub in over here. So 3 is equal to -2 plus b log 16 with base 4 can be written as log 16 over log 4 using change of base formula. Adding 2 both the sides, 5 is equal to b log of 16 can be written as 4 square over log 4. So 5 is equal to b. 2 comes down, and this will be log of 4 over log of 4. These two are gone. So 5 is equal to b times 2, or if we flip the equation, 2b is equal to 5, which means that b is just 5 over 2. So we got the values of a and b both. All right. This is calculator active. So we are given a situation where the number of downloads in thousands based on the number of days can be modeled by a log function. That function looks like a plus b, l, and t. We have to use the regression capabilities to find what a and b is. In other words, what is the, the regression equation. So let me just share the TI-84. Right, so we're going to go in stats. We're going to go in calc option, drop down to, you see this option 9, LNREG, that's a log regression. Click on enter. So here they are going to ask you a list. So for the list, you go on stat, you click on edit, press enter, and here you type in all the numbers. Once we do that, it's going to look like this. Now we click on stat. We go again in calc, linear regression, press enter. The list is already there, so we just go on the calculate option and press enter. So this is our log model. So over here, the answer to part A will be y is equal to 89.2043 plus 55.7983 ln x. That is the equation, and they're asking to use this model to find how many days will it take for them to reach 500,000 total downloads. And x are the number of days, right? Here, x are the number of days. So we just replace y with, but be careful, y is not really replaced by 500,000 because y is already in thousands, right? So you'll replace y with only 500. So 500 will be equal to 89.2043 plus 55.7983 ln x. Subtracting both sides with 89.2043, we get 410.7957 is equal to 55.7983 ln x. Divide both sides with this guy, we get 7.3622 is equal to ln x, and then we can just flip the equation. So ln x is equal to 7.3622, and to find x, we'll write x is equal to, the base is e goes on the other side, and 7.3622 will come here. So x will come out as 157.23. So these are the number of days as per this model. All right. Okay, they are talking about the earthquake measuring methods, and the Lilly empirical formula states that if the 200 kilometer away from an epicenter of the earthquake, if that's where we are measuring. So this is the formula where ml is actually the intensity and of the magnitude of the earthquake, and x is the maximum ground displacement in microns. So they have given at 200 kilometers, so they are just saying that you can use this formula. We are given 2 points, right? The first point is 5.2 magnitude at 21 microns. So 21 is the x value, of course, and 5.2 is the y value. And likewise 6.1, 180. So 180 is the x value and 6.1 is the y value. So the two equations will look like 6.1 is equal to a plus b log 180. And the second equation will look like 5.2 is equal to a plus b log 21. That's part A. For part B, they're asking us to solve for it. So in order to solve, I think I'm just going to subtract both of them because, A and A is gone, just like what we did earlier. So 6.1 minus 5.2 is 0.9 is equal to B log 180 minus B log 21. So 0.9 is equal to B parentheses taken out, log 180 minus log 21. Let's flip the equation. So B times log 180 minus I wrote 2L, 2O, so P log 180 minus log 21 is equal to 0.9. So B will be equal to 0.9 over log 180 minus log 21, which is approximately 0.964 46 up to 4 decimal places. So this is the value of B. To find A, let's plug in this in any equation. I'm just going to plug in the first one. So 6.1 is equal to A plus 0.9646 log 180. Let's flip the equation. So A plus 0.9646 log 180 is equal to 6.1. So A value will be 6.1 minus 0.9646 log 180. So the value of B is approximately 3.9246. That is the value of A that we have here. So the model that we have is A, which is 3.9246 plus B, which is 0.9646 log 10. That is the log of x, log of x. Base is 10, of course. This is the value of the magnitude of the earthquake. In the last part, they are asking that if the value of ML is 9.5, then what is the value of x as in the ground displacement? Let's replace ML with 9.5. So 9.5 will be equal to 3.9246 plus 0.9646 log of x. Subtract 3 this number both the sides, we get 5.5754 is equal to 0.9646 log of x. Dividing both sides with 0.9646, we get 5.7800 is equal to log of x. Let's flip the equation. So log of x is equal to 5.7800. So the value of x will be 10 raised to that number, right? 10 raised to 5.7800. So this value approximately comes out as 602,559.59 micrometers. That should be the final answer for this one.